Hey everyone! Today we're going to be looking at question 1 of Larson. This is a very interesting question because if you look at the sequence of numbers, what you'll quickly realize as you write more and more terms is that it becomes harder and harder to really understand or see a pattern. So let's start out first by looking at the question, reading it carefully. So the question is, beginning with 2 and 7, the sequence 2, 7, 1, 4, 7, 4, 2, 8 is constructed by multiplying successive pairs of its members and adjoining the result as the next one or two members of the sequence, depending on whether the product is a 1 or a 2-digit number. The call of the question is to prove that the digit 6 appears an infinite number of times in the sequence. Let's start out first by looking at the sequence and making sure that we understand it. So we start out with 2 and 7. And what we're going to do is we're going to multiply the pair. So we get 14. And then we adjoin the result as the next one or two members of the sequence. So that would be 1, 4. And then we next pair. 7 times 1 is 7. Tack it on the end. 1 times 4 is 4. Attach that to the end. 4 and 7 is 28. That on the end. And if you'll notice here, this is the same sequence of numbers that they've given us in the problem, so we have some sense that we're doing this correctly. If we keep going, let's just keep going because we don't actually have any 6's here yet. 7 and 4, 28. I think you'll notice that you're not going to get a 6 until you multiply 2 and 8 together, but let's just keep going here. 4 and 2 is 8. 2 and 8 is 16. 8 and 2 is 16. 2 and 8, 16. 8 times 8 is 64. Eight times 1 is 8. 1 times 6 is 6. So that's 8 and 6. Now, what you're going to notice here is that we have a lot of digits, and there's no real apparent pattern. But what we do notice is that there's certain numbers in the sequence that tends to generate 6's. For example, when we multiply 8 and 2 and 8 and 8, that generates 6's. So really the trick to doing this problem is looking at individual digits in groups and seeing what numbers those digits will generate down the line. So let's start out with just looking at 2, 7, 1. So the first three digits in the sequence, 2, 7, 1. Okay. So let's just look and see what numbers 2, 7, 1 will generate and down the line. Let's see if we can see any patterns doing that. So 2 and 7 is 14. 7 and 1 is 7. Okay, so 2, 7, 1 generates 1, 4, 7. Let's see what 1, 4, 7 generates. 1, 4 and 28. So 4, 2, 8. What do these numbers generate? Let's see. 4 and 2 is 8. 2 and 8 is 16. So that would be 8, 1, 6. 8 and 1 is 8. 1 and 6 is 6. And what you're going to notice here is that we're going to have a bit of an issue because now we have only 2 digits. And what you'll see is that these can really only generate at most 2 digits. And eventually you'll see that we're going to be getting down to only 1 digit. And so we're kind of stuck. 6 doesn't generate any more 6's here. So let's move on. Let's look at the next three digits. 1, 4, 7. Let's see what those generate. Okay. So 1, 4, and 7. We actually already have our work cut out for us. If we look up here, 1, 4, 7, eventually we're going to be stuck again, and we're going to be at just 6, right? If you look over here, we've already done that work for us. Okay. What about 4, 7, 4? Let's look at that. 4, 7, 4. Okay, so 4, 7, 4. That's going to generate 2, 8 and 2, 8. Okay. This looks a little more promising. Let's see. Okay. And this will generate 16, 16, 16. What I'm going to do here is I think I'm going to not... I'm trying to avoid here having to write all these digits over and over again. Let's see if we can get away with just writing the first 4. So this will get 6, 6, 6. Okay, this looks a little more promising. 36, 36, okay. 3, 6, 3, 6. And then let's see what we get here. We get an 18, 18, 18. Okay. Now this is very curious because, well, let's continue around over here. I'm kind of running out of space here. I'm just going to draw the arrows going the other direction. And then coming all the way around here. Alright, so 3, 6, 3, 6 generated 1, 8, 1, 8, 1, 8. Let me just only again take the first 4 just to save them having to write so many numbers down. So 1, 8, 1, 8. Okay. Now, an important thing to realize here is that the numbers 4, 7, 4, at some point in this long sequence of numbers, you're going to be generating these sets of digits, correct? I hope that makes sense to everybody. Now, we get 8, 8, 8 here. So 8, 8, 8. And this will generate 6, 4, 6, 4. $64, $64, and this will generate, whoops, 24, 24, and 24. And I think what you'll see shortly, it's a little difficult to see actually. I think what I'm going to do is I'm going to erase some of the set above just to make more room here because we're having space problems. I think I've convinced you guys that these first 3 digits were not very helpful, or the next set of 3 digits. So we were here at 6, 4, 6, 4. Okay, and that was going to generate 2, 4, 2, 4. Now again, I'm not going to write the last set of 24 just because I don't want to have to write more digits than I need to. Now here's where the curious thing happens. You'll see we have 8, 8, 8. So if you notice, we have already done that part of the sequence, 8, 8, 8. So this will generate 6s, and then it will generate itself again. So it cycles back. So this is the key to the whole proof. See, because we generate 888 at some point in the sequence, and 888 will generate itself again, and because every time 888 generates, we're guaranteed to have at least 1 6, we now know that there must be an infinite number of 6s in this sequence. So an interesting way to prove this problem. It would be very, very difficult to see this if you had written out the sequence of numbers. You may not have ever recognized the fact that 888 generates this repeated pattern. So often the solution to the problem is right in the question itself. So just to recap, what we did was we looked at the first sequence, 271, and we saw that that took us nowhere. It led us basically to a single digit 6. And the same thing occurred for 714. But then 474 led us to realize that we would at some point get 888, and then 888 would cycle back and generate itself. But in the process of cycling back, it would generate 6s for us, and then itself again. And so this is the key to the proof. I hope you guys enjoyed listening.